Hey Algebra 2, welcome back to unit review of Unit 6, Rational Functions. We're working on page 2, so we're going to continue on the back side of your review sheet. So now, in this problem, number 11 on the back side, we're going to add two rationals. Okay, so when you add a fraction, let's say 1 over 3 plus 1 over 3, which is just 1/3 plus 1/3, you add the numerators. Oops, sorry about that. Fix that. There we go. So we add the numerators of these fractions, right? So this would equal 2/3. So we don't add the denominators. Same thing applies when we deal with rational expressions. So here, all I'm going to do is add this r plus 4 to the 3. And the denominator does not change. Now I need to make sure before I do that the denominators are the same. In this case they are. So we can just add the top. So r plus 4 plus 3 would be r plus 7. All over 4r squared minus 13r minus 12. Now, the next thing you want to do is we want to see maybe I can cancel out a factor on the bottom and the top. So let's go ahead and try to factor out this trinomial here. So let's write my binomials. And I think because I have a 4 over here, I think what I'm going to do is do my magic x and then do the a times the c, which is negative 60, or 4 times negative 12. And then I put the negative 13 down here. And then I have to think to myself, what two numbers multiply to 60, but add up to negative 13? Well, let's see. So if I had 20 and 3, no, that doesn't work. How about 15 and 4? No, that doesn't work. How about 12 and 5? That doesn't work. How about 30 and no, that's way off. 6 and 10? No, it doesn't work either. And you know what? There's nothing. So if you can't factor it, well, that's it. Then we just leave it there. Okay, so sometimes you might work through these and see that, oh, well, I can't factor anything. Well, that's it. You got to stop there. And you just leave it like that. Okay. Now, again, we have the same denominator, so we can go ahead and add our numerators together. So 2n plus n is 3n minus 3 over 8n squared minus 4n. Now, we can see if we can factor out something here. So let's try to factor out a GCF from both. GCF here on the top would be a 3, n minus 3. And the bottom, we would have 4 be our greatest common factor. So we're left with n. Actually, let's do an n as well, because we have an n in both terms. So then we can do n minus 1. And even after that, we don't have anything. So we can just leave it in a factor form, just like that. Okay, so there's nothing we can cancel out. Okay, so that's another problem where you just leave it as is. But you want to try and cancel something out if you can. Now, here's a problem where we don't have the same denominator. So we need to find the least common denominator in order to add them. So, in order to do that, if you remember, let's say I have 3 over 2 plus 2 over 3. Well, to make these denominators the same, I would say, well, if I multiply this times 2 and this times 3, well, then that would make them the same. And then I would have 9 over 6 plus 4 over 6. And then I have common denominators. But all I did, if you notice, is on this side, I multiplied times the denominator on the left. And on this side, I multiplied times the denominator on the right. So I'll do the same thing here. So here, let's multiply. Let's actually move this out the way. Oops, sorry. Okay, move this over here so we have a little bit more room. Okay, let's move this up so we can focus on the problem. And here, I'm going to multiply v plus 2 over v plus 2. because I'm multiplying times the denominator from the left. And then here, I'm going to multiply times the denominator from the right, 3 over 3. So now my new expression will be 6 over 3 times v plus 2. And I'm going to leave it factored, plus 3v. Now remember, the numerator I can multiply, and we want to multiply that so that we can add the top. So then I'll distribute this 3v, but the denominator, leave it factored. So the top, 3v squared plus 6v over 3 times v squared. Now we can add, let's just leave it that way. Now we can add the numerator. So now 6 plus 3v squared plus 6v is just 3v squared plus 6v plus 6. And I put it in standard form from the highest degree to the least. Now we have 3 plus v. 3 times v plus 2. So let's go ahead and see what we can factor here. So the bottom we've already factored out. So let's see what we can do with the top. Well, right away I notice that there's a common factor between each of these coefficients. 3, 3, and 3 can all be taken out of each. Okay, so I'll take out a 3, a GCF of 3, and then I'm left with v squared plus 2v plus 2. All that over 3 times v plus 2. And now I can cancel out some factors. Boom, right there and there. Now, if I sit here and try to factor out this trinomial and do my magic x, after a while I'm going to get stuck because there's nothing that I can multiply to equal 2 but also add to 2, because the only two numbers I can multiply to are 2 and 1. So I can't, there's no way combination of that's going to work to factor that out. So we leave that as is. So then we're left with, my final answer is v squared plus v, sorry, not v, plus 2v plus 2 all over v plus 2. Okay. Now we'll go over to the next one. Now I'm going to apply the same principle here. I multiply the denominator on the right times the denominator on the left, and vice versa. That way I can get the same denominator. So I'll multiply this denominator times x plus 1, and this denominator times the other one, the other denominator to the right, which is x plus 2. And like I told you before, just leave the denominator factored out in case we can factor out some a GCF or a factor in the next step. So, but the numerator, go ahead and multiply those and distribute them. Okay, so I'm going to distribute this 2x to that binomial and this 4 to this binomial. So now I have 2x times x, which is 2x squared, 2x times 2, which is 4x, and then all over x plus 2 and times x plus 1 minus, don't forget about that minus in the end, 4 times x, which is 4x, and then 4 times 1 is 4, all over the same denominator, x plus 2 times x plus 1. Now just remember, I've got a negative here. So what does negatives do to our expression? It changes the signs to the second expression here. Okay, it's like we're distributing this negative here. So at the same time that I'm going to combine, so I'm going to distribute that negative. So first let's write my denominator, and then I'll write the expression on the left, so which is 2x squared plus 4x. Then as I write it, I'm going to distribute this negative. So now minus will change the sign of this 4x, and it'll change the sign of the 4. So now I have minus 4x and minus 4. Now, as you guys can probably already tell, I can actually eliminate some of these terms because I have 4x and 4x, or sorry, 4x minus 4x, so that just goes away. And so what I'll do is bring this up here and rewrite it with 2x squared on top minus 4 and x plus 2 on the bottom times x plus 1. And if you haven't already guessed it, let's try to get a GCF off of the top of there. So, let me think. Well, I could take out a 2, but I can't take out x from the other term. So it looks like I'm going to just have 2 out of there, and x minus squared minus 4. And x plus 2 times x plus 1. And some of you think, well, I guess that's it, right? X squared minus 4 can't cancel out with the x plus 2 and x plus 1. But you've got to remember that x squared minus 4 can actually be factored itself. Remember that this is a perfect square, this is a perfect square, separated by a minus, so we can actually factor that out into 2 binomials. So let's do that. So now I still have a 2 up here, and this factors out to x here, and then minus 2 and plus 2. Okay, so now I have x plus 2 here, times x plus 1, and now we can finally cancel something. My favorite part. Woo! Love canceling. Cancel factors. There we go. Won't let me choose my red. Okay, so boom, gone, boom, gone. X plus 2 and x plus 2. And there's nothing else that'll cancel out. So now, sorry about that. So now I'm left with this 2 times x minus 2, so let's distribute that back to x minus 4. But remember, leave the bottom factored, but of course that really doesn't factor to any. That won't multiply to anything anyway, so we can just leave it as x plus 1. And actually I don't even need these parentheses, so let's just put x plus 1. And then we're done. Okay. So just remember on that one, make common denominator, and then combine the top here, distribute the negative, combine like terms, and then see if you can take out a GCF here at the end, or find a common factor. So now we're going to do solving equations, or rational equations. And one thing to remember is to check, for extraneous solutions, excluded values. Values of our solution that are going to make our original equation undefined. So let's start there first. Okay, so in order to find that, I would need to figure out what is going to make my denominators here in this expression, looking at number 15. What are the numbers going to make it 0? Well, if I plugged in a 0, that makes it 0, and that's it. So we just got to make a note of that off to the side, just so that we can remember if in the end we end up with 0 in our solution, then we want to cancel that one out because that won't work. Okay. So now what we need to do is you want to factor out each of these denominators. So what I like to do is break them down. So this is n plus n. This is 2 times n times n. And this is 2 times 2 times n times n. Now I need to, in order to work this problem out in a nice way that's easy to work with, I want to cancel out all these denominators. So I've got to figure out what can I multiply to each of these rationals so that all of the denominators cancel out. Well, if I only multiply n and n here, that will cancel this one out, but here I'm still left with a 2. So that means I'm also going to need to multiply a 2, n and n, n and n. But if I do that, that will cancel this one out, because I'll have an n and n cancel out. That will cancel this one out, because it's basically canceling this, multiplying by the same thing. But it will not cancel this rationale out, because I'll have an extra 2 here that I need to multiply. Okay, so that means that I'm going to have to multiply each rational by this number here. So first thing I like to do with these is to make it easier when we're writing it out, spread your problem out. because you're going to be multiplying times these binomials, and it gets kind of can get messy if you keep it all together. So first let's do, I'm going to keep it factored out, n times n equals, and spread it out like I'm doing, 3n minus 18 over 2n, 2 times n, and then plus, let me zoom out a little bit, plus 3n plus 6 over 2 times n times n. Okay, so now we figured out that I have to multiply it times this number here, 2 times n times n. So I'm going to multiply this here times that here and all the way across. Because remember, you got to multiply the same thing to each expression or each rational in the equation. Once you do something to one number, you got to do it to all of them. So now what I can do is go across and cancel out factors and see what I'm left with. Now here I've got an n here, so I can cancel one in there, one in there, one in here, one in there, and I'm still left with 2 and 2. And then here I'm going to cancel out 2, 2, n, and n, but I'm still left with a 2. And then here over here on the right, I'm going to cancel out 2, 2, 2, 2, n. Alright, so that one completely cancels out. So now let's distribute what we have left. I'm going to do this in a bit longer steps. So here I've got 2 times n plus 6. So 2 times 2 is 4, so let's just write that out. 4 times n plus 6. And the denominator canceled out. That's what we wanted. So we're just left with this 4 times n plus 6. And then over here, I've got a 2 times this binomial here. So I got 2 times 3n minus 18. Plus, over here, everything canceled out, so all I have is just 3n plus 6. And now let's distribute what we have left. So 4 times n times 6. So we got 4n plus 24 equals, distribute the 2 here and here. So we have 6n minus 36 plus 3n plus 6. Now, if you haven't already guessed it, now we can just combine like terms. So here on the left, we don't have any like terms. But here on the right, I have an n term here. So we can combine those. So let's just rewrite the left because nothing can combine here. Alright, so 6n plus 3n will be 9n. And then we can combine negative 36 and plus 6, which combines to negative 30. So now, if you notice, I have n, a term with an n here, and a term with an n here. So I want to isolate the n on the left side, and I want to isolate the numbers on the other side. So what I'll do is let's add and subtract to remove or to move some of these terms. So let's move the 24 from this side, cancel it out, and subtract it. So we'll subtract it here. And then we're also going to remove the 9n here by subtracting it from this side and subtract it here. So now let's go way over here, since we're kind of running out of room here. And let me zoom out a little bit so you guys can see. So now I will have, let's see, 4n minus 9n is going to be negative 5n equals negative 30 minus 24 is negative 54. Okay, so now I'm going to do divide by negative 5 to isolate the n. So now these negatives will cancel out and become positive, and now I have 54 over 5. And I don't think, there's nothing that I can reduce that with, because there's no common factors between 54 and 5, so it just stays like that. But I could also write this as a decimal and say 54 over 2, sorry, 54 over 5 is equal to 10.8. Okay, and that would be my solution. And just double check, go back and see if your excluded value over here, does it equal that one? No, because the excluded value was 0. So this 54 over 5 will work. Now number 16. Okay, let's move this up. Zoom in a little. Okay, so number 16, we're going to start it off the same way. I need to figure out what are my excluded values. Okay, so what I'm going to do is I'm going to need to factor out this denominator here so I can see what factors I come up with so I can figure out what my extraneous or what my excluded values are. So here, let's put an x and an x. And what multiplies to 5, negative 5, but adds up to negative 4? Well, that would be a 5 and a 1, and I need this to be negative 4, so that means my bigger number needs to be negative. So negative 5 plus 1 will equal negative 4. So now I know my extraneous values would be, if I plugged a negative 1 in here, that wouldn't be good. And if I had a positive 5 in here, that wouldn't be good either. And over here I have x plus 1 again, so it's the same as the negative 1 that we already found. So now, again, let's rewrite our problem. So now we're going to have 2x plus 4. And remember, leave it factored in the denominator so we can cancel out later. Spread it out. Let's put this a little closer here. Okay. Equals 1 over x plus 1. Okay, so now let's multiply a denominator. Multiply something that will cancel out all the denominators. Well, to cancel out this denominator over here, I'll have to do x plus 1. So let's do that to all of them. But in order to cancel out this denominator over here, I also have to do or multiply x minus 5. So let's also multiply x minus 5. Okay? All right, so now let's go ahead and cancel what we can. So now I've got x plus 1 here, that goes away. X minus 5 here, that goes away. Nothing cancels here because it's not a fraction. And then over here, just x plus 1 cancels. So now, over here on the left, I'm just left with 2x plus 4 minus, let's go ahead and FOIL all this. And let's leave it in parentheses because we got a negative there. X squared minus 4x minus 5. Remember, that's the same thing as our original denominator. Equals, let's see, we're just left with 1 times x minus 5, so x minus 5. Okay, now let's distribute this negative, or it's really a negative 1 that's in front there. So now I'll have minus x squared plus 4x plus 5. So really we just changed the signs. Now we can combine like terms on each side. Alright, so now let's combine the 2x and the 4x. But first let's put it in standard form. So I'm actually going to do write the negative x squared first. And add the 2x and the 4x, which is 6x. So I'm done with those. And then I have a 4 and a 5, so add those. So we'll have 9. And the other side we still have x minus 5. Now I've got an x squared here, and I think what I'm going to do is bring everything to one side. So let's subtract this x from here, and then we'll also end up subtracting it here. And let's add 5 here. So that eliminates that. And we'll add 5 here as well. Okay. Now we have negative x squared. And 6 minus x is 5x. And 9 plus 5 is 14. And then we have just 0 left over here on the other side. Now, really what we want to do here is we want to be able to factor. But we can't factor if our leading coefficient is negative here. So what you can do is you can do a couple things here. You can either factor out a -1, or you can just multiply the entire equation by -1. Either way works. What I'm going to do is multiply both sides by -1. So -1 times this whole trinomial and -1 times 0. Now you guys all know that 0 times this -1 is still going to be 0, but I still have to multiply both sides either way. So now let's rewrite that over here. So now we're going to have, let me zoom out a little bit so you can see it. So now we'll have x positive x squared minus 5 minus 14 equals 0. Now what we're going to have to do is factor this so we can figure out what actually makes this equal 0. So we'll have x here, What two numbers multiply to -14 and would potentially add to -5? Well, I think 7 and 2. And to be -5, I would need to have 7 be negative and 2 be positive. So now I know that if I plug in -2 here, that'll make it equal 0. And if I plug in 7 here, that will make it equal 0. So there's my solutions. But before I finish, I need to go back, check, is one of those numbers an excluded value or extraneous value? -1 or 5? No. So both of those work. Now the last problem on your page, number 17. Okay, so again, let's find those extraneous values. Extraneous value here, looks like we don't even need to take out a factor or factor out the denominators here. So for this first one, it would be 0. 0 would make this one undefined. And then for these two, n minus 2, 2 would be our extraneous value. So now let's rewrite our problem. So now I have n plus 4 over n minus 1 over n minus 2, and then 2n minus 8 over n minus 2. Oops. Okay, so now I know that I'm going to have to multiply n minus 2 here to eliminate that denominator, and so I'll do the same to all of them. And I draw, if you notice, I draw parentheses around the binomial that I'm multiplying because I want to make sure I remember that I'm multiplying the whole n plus 4 times n minus 2, not just 4 times n minus 2. Otherwise, I might make a mistake. Okay, so that will cancel out this denominator, but not the first one. So in order to cancel out the first one, I also need to multiply n. So I'll do that the same to all of them. Okay, so now let's go across and cancel factors. So in the first one, I can cancel n and n. Here, n minus 2 and n minus 2, n minus 2 and n minus 2. So now, here I've got n plus 4 times n minus 2, so I'll go ahead and FOIL that. So that'll be n squared. And then let's see, -2 plus 4 would be plus 2, so 2n. And then 4 times -2 would be -8. And then this next one is going to be minus 1 times n, so that's just minus n. And then equals, here I've got n times 2n minus 8, so I've got to distribute this n here. So now I'll have 2n squared minus 8n. Okay, so now what I want to do is get all my terms on one side, because I have an n squared here. So I know I'm probably going to have to factor at the end. So what I'm going to do is I'm going to actually move all the terms to the right side, so that, because I'm going to do that because I eventually want my n squared term to be positive. And so if I subtract n squared from this side, then I'll have 2n squared minus n squared, which is just n squared. Whereas if I did it the other way, and I did 2 minus 2n squared here and minus 2n squared here, I'd have a negative to the left. So I'm going to go ahead and help myself out and just do n minus n squared and minus n squared here. Okay, so now I'm also going to do, so get rid of this 2n from this side, so subtract 2n here, subtract 2n here, and then add 8 here. And also, I should have combined the like terms, but I didn't, but that's okay. So I'm also going to, add 8, and then also add n again. Okay, so now, that cancels out there. So now I'm left with 0 on this side, and I'll have 2n squared. So now 2n squared minus n squared is n squared. And 8n minus 2n is minus 10n. And then plus 8 and plus n. So now what I need to do is combine these terms here. And I should have done that in the step before, but that's okay. Some of you guys might make that same mistake, and you could just add it in the end. But it's not really a mistake, it's just doing it a little bit differently, because it's still going to be equal. So now negative 10n and n combine to be minus tongue-tied, minus 9n. There's 2 n's, too many n's. Okay, plus 8. So now I can see what will make this equal 0. Well, let's see. What multiplies to 8 but adds up to negative 9? Probably 8 and 1 would work. And it looks like they're both going to have to be negative in order to add up to negative 9. So now n can be 1, and n can also be 8. Now let's go back to our extraneous values. Is it either 0 or 2? It is not. So both of those are good. Okay, that's it.